Hello everyone, myself Sahana and today I am here to explain the topic on kernel modules. Read the contents, that is introduction, kernel module description, components, types of kernel modules, advantages of modules, at last is conclusion. Firstly, the introduction, that is kernel modules are pieces of code that can be loaded and unloaded into the kernel upon the demand. They extend the functionality of the kernel without the need to the reboot of the system. A module that can be configured as built-in or loadable. To dynamically load or to remove a module, it has to be configured as a loadable module in the kernel configuration. Sections of the kernel code that can be compiled, loaded and unloaded by independent of the rest of the kernel is the module that interfaces will allows the third parties to write and distribute on their own terms. Device drivers or the file system that could not be distributed under the GPL. The kernel modules will allow a Linux system to be set up with a standard minimal kernel without any extra device drivers built in. And the kernel module description is to be add a new code to a Linux kernel. It is necessary to add some source files to kernel source tree and recompile the kernel, but you can also add the code to the Linux kernel while it is running. A chunk of the code that is added in such a way is called a loadable kernel module. And the typical modules are device drivers, file system drivers and system calls. The three components to Linux module support is module management, driver, registration, conflict resolution. Firstly, the module management that supports the loading modules into memory and letting them talk to the rest of the kernel. That module loading is split into two separate sections, that is managing the sections of module code in kernel memory and the handling the symbols that modules are allowed to the ref. Second is driver registration that allows modules to tell the rest of the kernel that a new driver has become the available, and the kernel maintains dynamic tables of all known drivers and provides a set of routines that to allow drivers to be added or to removed from these tables at any time. The registration tables include the following items or the device drivers or the file systems and network protocols and the binary format. And for conflict resolution is that a mechanism that allows different device drivers to reserve the hardware resources and to protect those resources from accidental use by another driver. And the conflict resolution module aims to prevent the modules from clashing over access to hardware resources and to prevent the autoprops from interfacing with existing device drivers or to resolve the conflicts with multiple devices trying to access the same hardware. And the objectives of the kernel is to establish communication between the user level application and the hardware, also to decide the state of incoming processes, that to control the disk management, and its objective is to control the memory management and even the task management. When the kernel code must be a module is the higher level component of Linux kernel can be compiled as the modules. Some Linux kernel code must be linked statically, then component is included in the kernel or it is not compiled at all. Basic guideline is to build working base kernel that include anything that is necessary to get the system up. Everything else can be built as modules. Here we can see the types of the kernel modules, that is the hardware agnostic JKI modules and hardware specific vendor modules. This page provides an overview of both types of modules, that is GKI modules, that is generic kernel image modules, are used to deliver non-boot required kernel functionality that will separate from the generic core kernel. With the JKI modules, we can choose the specific kernel functionality to use often, reducing the kernel image size and runtime memory consumption. The reduction in size that will makes GKI well suited for Android Go devices and other resource restrict form factors. And GKI modules will also provide a mechanism to let the vendors incorporate new upstream features after the KMI freeze milestone. Thus, the built-in code can be replaced without building another image, whereas code delivered as a module that can be replaced by another module. Here we can see protected GKI module and even the unprotected GKI module. Firstly, a protected GKI module is delivered by Google that isn't restricted in any way and behaves as though it is built with a kernel after loading. Additionally, the protected GKI modules have the following characteristics such as the protected GKI modules have the access to non-KMI kernel symbols that aren't available to the vendor modules or unprotected GKI modules. Next, the protected GKI modules can export the symbols that become the part of KMI surface as long as those symbols are seated in a symbol list. Thus, the protected GKI modules can be overridden by vendor modules, and the unprotected GKI modules have the same access to exported symbols as vendor modules. Unprotected GKI modules can export the symbols that is exported by protected GKI modules, or the unprotected GKI modules must preserve any KMI interfaces as though the part of the code kernel. Thus, the unprotected GKI module can be overridden by vendor modules. Here we can see vendor modules. A vendor module is delivered by the partners to element the SOC and device specific functionality, and any existing kernel modules that isn't delivered as a part of the GKI kernel that can be delivered as a vendor module. Since one of the primary goals of the GKI project is to minimize the hardware specific code in the code kernel, the vendors can expect that the GKI kernel won't include the modules that are clearly managing their own hardware. For example, vendor ABC Inc. that is can expect that configs such as config of ABC SOC that is support won't be enabled either as a built-in or loadable GKI modules without their support. If a kernel driver or framework exists in ACK but isn't delivered as a part of the GKI kernel, the vendors can modify the driver and deliver it as a vendor module. Such modifications are discouraged for non-vendor specific modules because the same functionality might be delivered with a GKI kernel in a future release, when the GKI kernel will contain functionality that provided by a vendor module. The vendor module won't be loaded. For example, we can see the config of a underscore that is gray bus isn't set for GKI in Android 11. So, vendors may deliver the gray bus in the vendor modules. However, config that underscore of the gray bus might be enabled as a GKI built-in or module in Android 12, in which case that gray bus vendor modules won't be loaded. A best practice practice is to use the upstream version for non-vendor specific drivers if they are delivered as a vendor modules. You can deliver the vendor modules in the vendor or in the vendor boot image. The modules will required early in the boot process must be in a vendor underscore of the boot, that is there is no boot time cost associated with loading modules from vendor boot. Here we can see the advantages of modules. There is no necessity to rebuild the kernel when a new kernel option is being added. The modules will help find the system problems, such as if the system problem caused a module, just don't load it. And the other advantages is the modules will save the memory. Thus, the modules are much faster to maintain and debug it. The modules once loaded are in as much as the fast as the kernel. At last is conclusion. The kernels are very important for any operating system, that it basically manages operations of the memory and CPU time. The kernel has unique qualities, that it enforces its own rules and the stakes managing the entire system as the kernel does, or certainly higher. That said, the Linux kernel's complexity and barrier to entry is not qualitatively different from any other large software project. The most important step on the road to Linux development is the realization that the kernel is not something to fear. At last, thank you everyone.